Well, this is the coral nursery, and it looks magnificent, doesn't it? It's like a sort of giant buffet, except obviously you can't eat the corals. What they've done is they've taken a single coral outcrop, called a colony, and they've split it into fragments.
Mouse and his team have to tie the baby corals to the tables at first. Then they weld themselves to the plastic mesh. They can then be snipped off when they're ready to be tested. The light pen shows researchers how efficiently the corals are growing. Maya Kami, Mouse's assistant, helps with the task. The vertical sheets are coral nurseries too. It's all 5 meters beneath the waves.
And the coral is a remarkable organism because it is sort of part plant and plant animal. So if you look at this one, for instance, the colours in this, they don't come from the coral organism. They come from the zooxanthellae, the plants that live inside the coral organism. Take away the zooxanthellae and the colour goes too. Anyway, these are all genetically almost identical because they're taken from the same outcrop. So they'll be perfect for experiments on the surface.
Glue them, then give them some acclimation time for a week or so.
Maya, who accompanied us underwater, helps with tests in the laboratory. Early research suggests that jellyfish will be able to thrive in a more acidic ocean.
Now, what about these jellyfish? Do these sting badly, these creatures here?
No, that's Aurelia, or the moon jellyfish. It's a cosmopolitan jellyfish. In fact, you can find
you touch
it. I can touch it easily, and you can do the same. And
but what about the impact on the corals?
Creature.
Well, the species that forms these branching corals does well with more acidity. The round corals that underpin the reef do very badly. But here's the real worry. A humble algae is vital because it makes the cement which glues the reefs together. This pink algae hates acidity.
Cementing, calcifying algae that live within corals and keeping the reef together cannot survive under acidic conditions, and that we've seen that over and over again in our experiments, which means under acidic conditions the reef will just collapse.
Maybe it will adapt in time, these creatures?
I don't think so. The rate of change is so huge. I don't think the time scale allows these organisms to adapt.
If these reefs crumble, other reefs are almost certain to take their place. But Dr. Fine's colleague, who's been peering deep into the past, warns that it might take an inconvenient amount of time.
Corals have suffered a few large mass extinction events that were followed by ocean acidification. And maybe the most famous of them all would be the one that came about 241 million years ago, a huge event which caused an extinction of close to 96% of all the organisms at sea. What we can learn from the geological record are that there might be vast changes in the reef, but we cannot say that it will totally disappear. The fact is that it does bounce back. It takes 10 million years, so if you want to wait around for it to come back, you're welcome. But they will bounce back.
The corals will be fine. It's just us will have the problem who depend on the fish from the corals.
Exactly.
There are already so many threats to corals: overfishing, global warming, pollution. Scientists say that acidifying the ocean is yet another reckless experiment with one of the great life support systems on the planet.
The answer to protecting the oceans from increased acidity is the same as the answer to climate change: reduce emissions of carbon dioxide. It's as simple and as difficult as that.
Bye.